All right, this will be part 2 of your lymphatic system lecture. Today we're going to be talking about the immune system. So the immune system is going to be a special set of organs and cells that have the function of protecting the body from pathogens. We're going to have a few different structures that we're going to talk about in this lecture, primarily white blood cells and lymphatic organs. So your lymphatic organs are going to be things like lymph glands, lymphatic vessels, spleen, tonsils, appendix. We talked about those on the last lecture, so you should be pretty familiar with those. And then we'll also talk about our antibody system. So first, let's talk about what is a pathogen. So patho means disease. It is going to be a broad term for an infectious agent that can produce disease. We have a few different ways that this can happen. This can happen with bacteria, fungi, parasites, protozoans, viruses, and one you don't hear a lot about but does happen sometimes is prions. So try not to confuse bacteria and viruses. Remember, bacteria are going to be living cells. They can cause infection in specific circumstances. They can reproduce and survive on their own. And a virus is going to be a non-living infectious agent. It must infect a living cell, and it cannot reproduce without a host cell to infect. We're going to talk about a couple different types of immunity, innate and adaptive. Innate immunity is going to be non-specific general protection. This is going to be what we're born with. This is where we get our rapid immunity responses. These are going to include external barriers like the skin, the mucous membranes, and some internal barriers such as like cells and chemical signals. The part of the immunity cycle that fever and inflammation are is going to be in this innate or non-specific general protection. We use fever to indiscriminately kill whatever has invaded the body. And this type of immunity is mostly going to involve neutrophils, basophils, eosinophils, macrophages, natural killer cells, and inflammatory proteins. Conversely, we have adaptive or specific immunity. This is going to be specific protection for specific pathogens. This has to be learned by your immune system. This type of immunity is typically going to have a way slower response. This is going to include your antibody-mediated and cell-mediated responses. And don't worry, we'll be talking way more about all of this stuff. This is just a big overarching slide to kind of allow you to put each of these into two boxes. So our adaptive or specific immunity is mostly going to involve B cells, T cells, dendritic cells, and antibodies. This type of immunity can adapt and change throughout our lifetime. So that's pretty cool. Okay, so let's talk a little bit about our innate physical and chemical barriers. We talked a little bit about these on the last slide, but I just want to go over them again. So this is going to be things like our skin and hair. This acts like a physical barrier to pathogens. Our secretions, such as oil from our oil glands or sweat, can help to kill or slow pathogens. We have a lot of things in our body that are acidic, like our gastric acid in our stomach. This makes it really, really hard for pathogens to survive. Our mucous membranes can secrete saliva, mucus, digestive enzymes, and all of those things trap and can kill pathogens as well. So our enzymes and our tears and saliva and mucus are really, really helpful to us in the innate immune system. And again, we talked about how our innate immune system is concerned with this inflammatory response. In this inflammatory response, mast cells and basophils are going to release histamines and cytokines in response to a pathogen. These chemicals are going to cause fluid to accumulate and blood vessels to become more permeable. This allows other cells, like our white cells, to go in and attack the pathogens way more easily. And then fevers are going to speed up the immune response and slow down the pathogen as well. Let's talk a little bit about antimicrobial proteins. So these are going to be proteins found in the blood and interstitial fluids that are going to naturally discourage microbial growth. We have interferons. These are going to be proteins produced by infected cells that signal other nearby cells to produce antiviral proteins to try to inhibit this viral replication. And then we also have the complement system, and we'll talk a little bit more about what the complement system is, but these are going to be molecules that are going to kind of enhance the immune response to help, like it can attract macrophages, it can cause lysis, which is going to be rupturing of the cells. It can do a whole lot of things to kind of neutralize these foreign invaders or pathogens. I should say, whenever you hear that word, foreign invaders, that means stuff that is not of the body that is infectious. So let's talk a little bit about natural killer cells. Natural killer cells are going to be a special type of T cells that can kill viral or infected cells and cancer cells. They have a really rapid response to infection, so usually we see these at about 72 hours or less. These are also, the big takeaway here is that these are capable of recognizing and killing cancerous cells. Because cancer cells replicate so rapidly, they will often quickly develop mutations that can help them get around these natural killer cells. But without mutations, the natural killer cells are actually pretty good at hunting them down and killing them. Well, we've talked a lot about phagocytosis in other lectures. So phagocytosis literally means that the cell eats something. There are specific cells that do this, usually neutrophils and macrophages. These are going to engulf and destroy pathogens. They can also pick up like debris from these destroyed pathogens and spit that out so that other white blood cells can learn what they should be looking for to track these down. We're going to talk about a few different kinds of responses in our adaptive or acquired immunity. Remember, this is our specific immunity. We have what we call an antibody or humoral response, and we have a cell-mediated response. In that antibody response, this is going to be primarily associated with B cells. These are going to be activated by the antigen-presenting cells from that innate immune response. And then after this, these are going to divide many B cells and start secreting specific antibodies, which are going to tag a pathogen for destruction, essentially. In our cell-mediated response, we're going to have T cells, and these are going to also be activated by the antigen-presenting cells from the innate immune response. So remember, the innate immune response is happening first, right? This is our shorter term, whereas the adaptive acquired immunity is our longer term response. At this point, we are going to create many T cells, and these are going to directly identify and destroy the infected cells based on the antigen that was attached at the previous step. So let's talk a little bit more about what this adaptive response looks like. In this adaptive immune response, we have lymphocytes. These are going to be white blood cells involved in the adaptive immune response a few different ways. And again, T cells and B cells. We talked about these on the previous slide. They're very important. I want you to remember this. So I just want to point them out again. So T cells are going to mature in the thymus. Examples of T cells are going to be like helper T cells or cytotoxic T cells. And again, these are involved in the cell-mediated response. Whereas B cells are going to stay and mature in the bone marrow and produce antibodies. Notice your highlighted letters there. I did that to help give you something to grab a hold of for your studying. A few examples of B cells are going to be our plasma B cells. And again, these make antibodies. I really want you to make that association that B cells are making antibodies. These are going to be involved in the antibody or humoral mediated response. So let's talk a little bit about some vocabulary words that I just kind of glossed over a little bit. So just in case you were going, what is that? An antigen is going to be a substance that is going to elicit an immune response. And an antibody is going to be a protein made by B cells that are going to bind to antigens. I put this little slide in here. I don't need you to necessarily memorize this, but there are a whole lot of vocabulary words that are used in this chapter. And so I wanted to give you a slide where they're all kind of here, showing you a little picture of what this looks like along with a definition so that you are able to use that for your studying. So an important takeaway here is that antibodies are what we are using to mark our cells for destruction. So essentially they act like little flags. So like when you go to used to go to Casa Bonita and you'd put up your flag saying like, I want more food or I want more chips or whatever, like antibodies do that job for the cells. So when an antibody is attached to a cell, that puts a little flag on it to say, hey, this is a pathogen, this is an invading cell, we don't want this here, somebody come take care of that. Sorry about that, I had to pause for a second, so if this video feels a little disjointed, that's why. Okay, so picking back up, we're still talking about the adaptive immunity antibody-mediated response. The important takeaway here is that you're going to have these antigen-presenting cells. We also call these dendritic cells. Their job is going to be to engulf the pathogen. They're then going to break it up, and then they're going to kind of display these pieces of antigen on themselves. So what the purpose of this is they're essentially saying like, hey, there's this really suspicious thing going on over here. I'm making like a giant flag to throw up so that these helper T cells can come in and recognize that we have a problem here and move on to that next step in that antibody cascade. Okay, so this begs the question is how are these B cells actually activated? The way that this works is the first thing that is going to happen is that dendritic cell or antigen presenting cell is going to present the that antigen binding to its outside. It's going to present that to the helper T cell. At that point, there's going to be a B cell receptor that is going to be activated by that helper T cell. And this activation is going to be enhanced by cytokines. So at this point, we end up with millions of clones of B cells that are made specifically for that specific antigen. We're going to have plasma B cells. These are going to produce antibodies specific to the antigen during infection. And we're also going to have memory B cells. These are going to have the same receptor, but they're really long-lived. And the reason why this type of cell is so important is because when we are then exposed to that pathogen in the future, these are the cells that are going to remember that and respond accordingly. So these are really, really helpful in our future infections. So again, the main thing here, I just broke this down into a much smaller slide. The main things I want you to remember here is just the three-step system, where first the dendritic cells are going to present this antigen to the helper T cells. This is going to signal the cytotoxic T cells to head to the battlefield and infect those infected cells. And then we have these memory T cells that are going to be created to kind of patrol in the short term and make a memory for the long term so that when we encounter this antigen again, this pathogen again, we are ready for it. The last thing that I want to talk to you about is immunological memory. So your adaptive immune system is going to learn over time. When you have a primary immune response, this is going to be your first exposure to an antigen. At that point is when we create these memory cells. And you can see on your graph here, we have first exposure to the antigen or pathogen, sorry, I keep doing that, at 0, and then our graph is going to move up, mount an immune response, and then the second time that we are exposed to that pathogen, we get a much greater immune response, right? So that secondary immune response, it is going to mean that anytime we have a repeat exposure to this, we're going to have a faster and greater response. So that response will get way more quick, but also the magnitude of that response is going to increase drastically. And this is because the immunity has been built. So your immune system is ready to react quickly enough, sometimes to a point where we don't even feel sick. That is all that I have for you on this immune lecture. As always, you guys have my number, you have my email, all the things. If this material just isn't sticking and you need extra help, text me, email me, whatever. We'll make a time to meet and hang out and figure it out. All right, thanks.